Hi, welcome to Mrs. Thompson's classroom. Today we're going to continue our unit on trig identities. Specifically, we're going to look at our half angle formulas. So let's just start by writing them down. They look like this. Now all of these are derived from our cosine of 2x formula. For instance, we know that cosine of 2x can be written as 2 cosine squared of x minus 1. Now let's just do a change in variables. If we think about this, if we let this be cosine of y, so y equals 2x, then that means that x is y over 2. Okay, so I can do an exchange of variables like this. Okay. And so now if I solve for cosine of y over 2, I'll get cosine of y plus 1 equals 2 cosine squared of y over 2. Then I can divide by the 2. And then finally, if we take our square root, we get that cosine of half of an angle equals the square root of cosine of y plus 1 over 2. And so this matches this. Now again, because I took the square root, it would be plus or minus square root. And so how do I know which one it is? Because cosine and sine and tangent are all functions, so they must only have one answer. Well, that one answer is determined by where on the unit circle we are. So whichever quadrant x over 2 is in will determine if I'm plus or minus, okay? Because we can remember the signs around the unit circle, okay? So if I'm in quadrant 1, all three of these ratios are positive. If I'm in quadrant 3, sine and cosine are both negative, which would make tangent positive. So we just have to figure out what quadrant is this one in. To determine whether it's plus or minus. Okay, so let's take an example of how we might use this. So for instance, they might ask us to find the sine of 5 pi 12ths. Well, 5 pi 12ths is actually 1/2 of 5 pi 6ths. So because it's the half of something, I can use my half angle formula. And for sine, it's 1 minus cosine over 2. So then I go to my unit circle and I find cosine of 5 pi 6, which cosine of any pi 6 is a square root of 3 over 2. And 5 pi 6 is in quadrant 2, so it will be negative. Okay, so then those two negatives make a plus. And I can do the addition in the numerator by getting a common denominator. So it looks like this. And that would become a plus. And then, of course, I don't like fractions within fractions. So now I have 2 plus the square root of 3 all over 4. Now that can simplify one step further. 2 plus the square root of 3, and then all of that over, what is the square root of 4? Well, the square root of 4 is 2. So I end up like this. Now, stopping here is completely fine and sufficient, or we can come here. The other way I'll see some people simplify this is by breaking the fraction apart, and you end up with it looking like this. However, if you're going to do something else with this, like maybe we want tangent, so we're going to do sine over cosine, so we're going to do some further things with this, this one is not as convenient. The last one is the best, but all three are sufficient solutions, are accurate solutions. Okay, let's do another one. Let's say we know sine is 2/3. And we know that our angle is in quadrant 1. Okay, so we can use these formulas to figure out what the sine of x over 2, the cosine of x over 2 would be. But the first thing I have to know is what is the cosine of x. So I do know that cosine squared is equal to 1 minus sine squared. So that would be 1 minus 4/9. So that's 5/9. So that means that cosine is equal to the square root of 5 over 3. Now, because I'm in quadrant 1, I do know that this is positive. So if I replace that value inside my square root, I'll get 1 minus the square root of 5 over 3, all over 2. So if I finish that simplification, I'll do the subtraction in the numerator. Okay, and then I'm dividing by 2. So I end up with 3 minus the square root of 5 over 6. Okay, if I do cosine, well, cosine is exactly the same, but it's a plus. So it will just end up with 3 plus the square root of 5 over 6. Now, let's double check whether these square roots should be plus or minus. If x is in quadrant 1, this is angle x, and I divide x by 2, I will still be in quadrant 1. Okay, as the angle gets bigger and goes into quadrant 2, and I cut it in half, x over 2 will be in quadrant 1 again. As I go around to quadrant 3, then cutting it in half is going to bring me back up to the top of the circle, and so on. So you need to check and think through that as you determine. But both of these are going to be plus. Now that makes tangent sine over cosine. Now when I'm dividing the fractions, that means I'm actually multiplying by the reciprocal. So I could write this way. Okay, let me clean that up a little bit. And so in doing this, I now see that these 6's will cancel. Because keep in mind, when you're doing square roots, multiplying square roots would allow me to write this way. And so this will definitely allow the 6's to cancel. And I just end up with 3 minus the square root of 5 over 3 plus the square root of 5, all underneath the square root. Okay? So practice those a little bit. Hopefully this gives you a little understanding of those formulas. Let me go back and just show you those one more time so you can see what those look like. And if you've got any comments, be sure to write them below. And if you're in class with me, I will see you next time. Be sure to just bring your questions with you, and we'll do some more. Talk to you later. Thanks for joining us.